Okay, so once again, welcome everyone to the channel, and this is the part 9 of our binary tree series, in which we're gonna solve the question number 114, named as a flattened binary tree to linked list. So here we see the question that what question says. Like here we gonna given the root of a binary tree, and we need to flatten the tree into a linked list. Like here we see the diagram in which we see there's a tree present, and we have to just flatten the tree and write in the form of the linked list. Like in the input we see the 1 2 5 3 4 null and 6, and in the output you basically see 1 comma null comma 2 comma null comma 3 and so on. So as an example 2, you can also see there's a no root, means there's a no tree present in the diagram, so we need to present return this statement. And in the third example you have to say 0, then you have to return the 0. So here we write, I write a base condition for your understanding that what the code I gonna write have a, something circumstances that like you can't understand, but you have to just focus on the main important 3 lines that I gonna write here. So after understanding the question, I hope you understand. So here we're gonna write the code. So basically we need to make a function, let's suppose name a flatten, and apply the base condition to check if there is a root is equals to null pointer, then we have to return the return, means we have to return back in the statement. After that we have to write a flatten comma right, flatten comma left to check each node, and to print each node at the in the form of the linked list. So here we write flatten, okay, tree node. So this is the base condition, and here we check if our root is equals to null pointer. Sorry, here we check if our root is equals to null pointer, then we have to return. So we here apply this, and we have to return this into here. Return. Okay. After all that, we just have to recursively call the preorder. Basically we have to apply the preorder concept in this question, and not exactly the preorder, we just have to apply a reverse order of a preorder. What is preorder? So basically we write a root comma left comma right. Firstly we have to print root, then we have to print right, sorry, left, and then you have to print the right. So if we reverse the preorder, then we have to firstly print the right node, then after left, and then after node. So this is the concept, and we exactly doing the same thing in this code. Don't worry about the the code. Basically we have to dry run this code in another manner. I also have a docs page for you for the clear understanding. But before the understanding, you just have to understand the code, that what I say to you and what I need to understand. Root dot left, and then again we have to recursively call the function flatten and check root left. Okay, this condition helps us to iterate in the each node of the tree. After that, these are 3 important lines you need to write in your code, like root comma left is equals to null. Okay, and then root right. Firstly you see the code, then I have to then I understand you that what I just write in the code, and how the compiler understand this code, and how we're gonna see the concept which is applied in this code. The right equals to right next. Okay. Okay, so if you're asking what is the right next, so right next is basically a node, let's suppose tree node equals to right next. Here we assign this into, sorry, okay, this to null. Okay, so right, okay, so root right equals to right next, and after that we just iterate the right next to the root. Sorry for the spellings. Okay, so right next is equals to root. So here we using an attachment statement to attach each node to other node, So basically there are some confusing part in this code, but for not, for a clear understanding, I just have okay a notes for you where we write on the each example which is present in the question. So firstly, we just see the docs where we write on of a code given a binary tree flatten into the linked list in the place. That means the each node set left equals to null. Okay, in the first step we do left equals to null, and then we are doing a recursive try run each step by step. Okay, you say this. So we will call a flatten one will means right next equals to null. Okay, that's a part of a code. After that we just call flatten one means root equals to 1. Basically we just apply the root comma left, sorry, root left equals to null pointer. Then we first flatten the 1 comma right which stores the value 5. Then we call again flatten 5 which is equals to root equals to 5, and then again we flatten 5 equals to right which stores the value 6. Okay, we firstly move to the right part of the tree, then after root, and then after left. Okay, then after we call a flatten 6, and flatten 6 comma right equals to null pointer means this is the last node of the tree. Then we return back in the statement and we backtrack each step so that we got the node at the right place. And after backtracking we just return to the previous call flatten 5. Then after back to the flatten 5 which is flatten 5 left equals to null, then we have to return, and we again apply both the 3 line I write in the question, which is 5 right equals to right next 6, and the right next 6 pointer will attach to the 5 right. Okay, this is a little bit confusing, but I hope you understand. And then we are now in flatten 1. Again we flatten 1 equals to left, and then we move to the left point, again call 2, and a flatten 2 comma right which is equals to flatten 4. When you again flatten 4, you just got the flatten value 3, and that's on. And then you have the last node which is a 1, and your final a right links equals to this 1 2 3 4 5 6, which we need to print in the output. And each node left equals to null, and the right points to the right next in the preorder. We basically use the backtracking method of the preorder traversal in this code, and our final flattened tree structure is in this form 1 2 3 4 5 6. Okay, so I hope you understand the dry run of the code, and here we run this code, checking this is the question is right or not. See, there's a compilation error, means I do not apply a semicolon on this part. Okay, so after applying a semicolon, here we wait. Yes, both the 3 test cases are the pass, and this is the a big N code of the one of the best approach to solve this part of question and this types of question basically in the Leetcode. Yes, this is the big O N time complexity code, and a space complexity is also a big of 1. Basically we do not store any value, we just have to iterate each node at each level after the with the help of a backtracking. And here also we write a step explanation with basically we do a recursive call of the right first and the left, and then we apply a new variable which is a new node right next, keeps track of the next node in the preorder. After that root comma right next attach next node, and then right next again move right next pointer from the previous call. Basically it is attached to the a previous one. And then the final statement root left, remove left child in the linked list style. Okay, so I hope you understand the code, and this is for today. Meet you in the part 10.